Alright, we're looking at the homework on page 87 first. 87, 1 through 4. In number 1, a truck driver drives to deliver some furniture. He goes 8 kilometers east, turns around and goes 3 kilometers west, and then turns around again and goes 12 kilometers east. And we want to know displacement and distance. Well, his distance traveled would be sort of like his odometer would show. He went 8, and then 3, and then 12. Well, 8 and 3 is 11, plus 12 is 23. That's his distance traveled. His displacement, on the other hand, we'd have to line the vectors up, and just for visual sakes, I'm just going to stagger them here. So he went 8 forward, 3 back, and then 12 forward again. Overall, he went 8 minus 3, which is 5, plus 12. 5 plus 12 is 17. His displacement is 17. We can do this by assigning this vector, which goes in the opposite direction, a negative sign. And so we'd have positive 8 and positive 12, which is 8 and 12. It's 20. And then 20 minus 3 is 17. We can line them up in a number of ways. We can go nose to tail, and then come back to here, which would be 17. But that's how we do it. We rearrange our vectors according to positives and negatives in the same axis. So whenever things are in the same axis, if they are going one way, call that one way positive. If they're going the other way, call it negative. And you can combine them. Number 2. A pirate goes 45 meters north and 7.5 meters east. That's a right angle. And they want to know what overall displacement could the pirate have had instead. And the pirate would then have gone along this dotted line. So we're just going to use Pythagorean theorem. We're going to put 45 meters here on the y-axis, so to speak, on the north, and 7.5 meters here on the x, the east. So using Pythagorean theorem, 45 squared plus 7.5 squared equals c squared. And when you're done with that, you find out that it was only 45.6 meters off to the northeast. If you want to be specific about directions, and this is kind of a big deal, northeast isn't good enough. Northeast would only explain exactly a 45-degree angle out like this. We do not have a 45-degree angle here. We've got technically a 9.5-degree angle. When you're describing it, you want to use the words north and east, but it's a matter of, is this to the east of north or the north of east? This is off to the east side of north. If you are facing north, you're going to turn 9 degrees to the east. So it's east of north by 9.5 degrees, and we'll work on that skill right there later. Number 3, we're on a soccer field. Let's see. Emily passes the ball to Kara 6 meters across the field, and then Kara kicks it down the field to Louisa 14.5 meters. So we're going to use Pythagorean theorem on this one. 6 squared plus 14.5 squared gives us the final answer here. Our final answer is going to be on number 3, 15.7 degrees, or 15.7 meters rather. And we just want to know, when you're doing it, they give you words like across and down. Well, obviously, if you think about the meaning of those words, they do not mean in the same axis. They mean parallel to each other, or perpendicular to each other, I'm sorry. Then the hummingbird question. The hummingbird is 3.4 meters above the ground. The hummingbird flies forward 1.2 meters and then drops down forward 1.2 and down 1.4 meters. They want to know the displacement on the hummingbird. When you're encountering this problem, ask yourself, did the hummingbird take off from the ground in the problem? During the problem, it does not say that. This says the hummingbird is 3.4 meters above the ground. This is not a vector that we're going to work with. That's just information. The hummingbird is that far above the ground. It goes forward and down. It is displaced from here, this spot, right here, to here. So we want the vector that represents that right there. The 3.4 is just informational. It's not useful. So we need to take Pythagorean theorem, 1.2 squared plus 1.4 squared equals 1.8 when you square root. And there's your answers.